In this lesson, we're going to discuss how to write the equation for exponential functions. The equation for any exponential function is y equals a times b to the x. A is our y-intercept, b is our growth factor. This is the number that we're multiplying to get from one y value to the next, and our unknown x is the exponent. When we're writing exponential functions from tables, we want to begin by finding the y-intercept. So that's when x is equal to 0. So in this case, our y-intercept is 1 because when x is equal to 0, y is equal to 1. Then we want to find our growth factor. So again, we're going to look for the value that we're multiplying to get from one y to the next. And in this case, that value is 3. To get from one y value to the next, we can see that that's times 3. So our growth factor would be 3. Once we know what a and b are, we can substitute those into the equation. So y equals a times b to the x. A is 1, b is 3. So we have y equals 1 times 3 to the x, or just y equals 3 to the x. When we're looking at a graph, we're doing the same thing. We're looking at where it crosses the y-axis to find the y-intercept. So in this case, that's 1. Then we're going to take 2 consecutive points so that we can find that growth or decay factor. We want to look at the y values of those 2 points. So my 2 points we're going to look at are 1, 3, and 2, 9 because they're back-to-back. They're consecutive. I want to look at their y values because the growth factor is from one y to the next where we multiply. So again, I can easily find that by dividing those y values. So take the second y value and divide it by the first. So that y2 divided by y1 is the formula that we'll use here. So our second y value in this case is 9. Our first y value is 3. And when I do 9 divided by 3, that gives me 3. So I know to get from 3 to 9, I would multiply by 3. So my growth factor is 3. Then we can write our equation. Since we know what a and b are, substitute those in. So in this case, we would have y equals 1 times 3 to the x, or y equals 3 to the x. Be careful when dealing with word problems because word problems will give you the rate instead of the factor, and the rate is a little bit different than the factor. We can't just multiply by the rate and have our answer. The rate is a percentage, and so it will give us a much smaller value than what we're supposed to have. So in order to avoid that, we're going to use the formula y equals a, parentheses 1 plus or minus r to the x. We'll use 1 plus r, the rate, if it's an increase, if we're looking at an exponential growth, and we'll use 1 minus r if it's a decrease to get that decay. Again, the reason why we're adding or subtracting by 1 is it will give us the growth factor that we would multiply to get from one y value to the next, as opposed to the rate that they give us in the problem. Let's look at a couple of examples. So here we have 2 exponential equations, and we want to identify the y-intercept and the growth and decay factor. So in this case, our y-intercept is 5.2, so a is 5.2. When we're looking at our equation, y equals a times b to the x, because that's in the spot for a. And our b, our growth factor in this case, is 1.42. Again, we'll know that it's a growth factor when b is greater than 1. And we'll know that it's a decay factor when b is between 1 and 0. So that's when it's less than 1, but greater than 0, so that would be a fraction. So again, growth when our value is greater than 1, decay when we're dealing with a decimal number or a fraction. So when we look at the second one, we know that our y-intercept, our a, is negative 4. And we know that our growth, or in this case, our decay factor, is 0.82, because that number is smaller than 1. Now we want to write the equation given the graph and the tables. So again, when we're given the graphs and tables, we want to begin by finding the y-intercept and the growth or decay factor, and then we'll substitute in those values. So my y-intercept for my graph is going to be 1, because we know that it crosses the y-axis at 1. When we're looking at the growth factor here, I know it's exponential growth because this is increasing. We're going to look at 2 consecutive points. So my 2 points that I'm going to look at in this case are 1, 2, and 2, 4. And we want to divide the y values. We're going to divide the second y value by the first y value. So my second y value is 4. My first y value is 2. And I get 4 divided by 2, which is 2. So that tells me to get from 2 to 4, that would be times 2. And if I went from 4 to 8, if I went from this y value to this y value, that would also be times 2. So we know that our growth factor in this case is 2. Then we can write our equation, substitute it into that y equals a times b to the x. In this case, it'd be y equals a is 1 times 2 to the x, or just y equals 2 to the x, since anything times 1 is itself. When we're looking at the table, again, we want to find the y-intercept and the growth and decay factor. Now, we're not given the y-intercept in this table, so we're actually going to have to find it, and in order to find it, we actually need to find the growth or decay factor first. So let's start by doing that. So we want to look to see how do we get from 5.76 to 6.912. This is going to be tricky because we're dealing with decimals here. It's not easy whole numbers. So in this case, we want to use that same formula that we use for our graph, which is to take the second y value and divide it by the first. Again, you're using points that are consecutive, points that come back to back. So 5.76 and 6.192 are consecutive. So we're going to divide them. So I take my second y value, which is 6.912, divided by the first, which is 5.76. And when I divide those, I get a factor of 1.2. So that tells me that my growth factor here is 1.2. And that's going to be the same factor that applies throughout this whole table. Now we can use that to find the y-intercept. Now remember, to get the y-intercept, we need x to be 0. So that would mean I would need to go back twice to get to 0. So if I'm subtracting 1 twice, if I'm going back 2 times, that means that I'm going to have to divide. Since we were multiplying by 1.2, we're going to divide to go backwards. So I'm going to divide by that twice. When I divide 5.76 by 1.2, I get 4.8. And then when I divide 4.8 by 1.2, since I have to divide it one more time, I get 4. And so I see that my y-intercept here is 4. So now I have my two values here, and I can substitute those into my equation, that a times b to the x. A in this case is 4. B in this case is 1.2 to the x, and we'll just leave it as y equals 4 times 1.2 to the x. When we're looking at this third equation, this third table, again, it's the same thing that we had in the first. We're not given the y-intercept in this table, so we're going to go and find the growth or decay factor here, taking two y values and dividing them. So in this case, I'm going to take 165 and 123. My second y value is 123, so that's going to go on top. My first is 165, that goes on the bottom. Again, we're doing second divided by the first, so we'll have 0.75, which makes sense because our values are getting smaller as we increase throughout the table. So we see that our decay factor is 0.75. Then we can use that to go backwards in our table. So I'm going to divide by 0.75 one time, since I only have to go back once to get to 0. When I divide by 0.75, what we end up with is 220. Our value got larger, which it should if we're going backwards. And so I see that my y-intercept is 220, and now I can substitute those into my equation. So again, a was 220, so we have 220 times 0.75 to the x. And so this is how we're writing our exponential equations here. Now when we're given a word problem, such as this one, where we have the population of Dulles has been decreasing, again, that word decreasing is important. That lets me know that I have a decay. At an average annual rate, again, this is the rate, not the factor, so a little bit different here, of 5%. The population was 1,200 in 2005. We want to write the equation for the population after 2005. So we have a couple options here. The first option would be to utilize the table to find the values and then write the equation from the table. So if I know that I'm decreasing by 5%, well, if I start off with 1,200 people in 2005 and I take 5% of that, so I multiply by 0.05, I know that that's 60. So we know that our value decreased, our population decreased by 60 students the first year. So that would leave me with a total of 1,140 students. And if that pattern keeps up, well, we know that 5% of 1,140 is 57. And so that would give me 1083, or 1,083 students. And then keeping that pattern up, again, times 5%, that would be about 54. So that would give me 1029, or 1,029. And then, again, one more time, would give me, it's about 51, so we lost another 51 students, which would give me a total of 977. So if we continue that pattern, we would just take 5% and then subtract. And then we could find the pattern that way. Again, using our formula that we were using, that y2 divided by y1, so that I can see what am I multiplying here. So my second y value is 1140, my first is 1200, and if I divide that, what we see is that our factor here is 0.95. We know that the y-intercept here is 1200 since that's the year that we're starting off with. That's our initial value. So if we're going to write the equation y equals a times b to the x, that would be y equals 1200 times 0.95 to the x. Again, that makes sense with what we were talking about because it's the decay, and so we still have a number that's less than 1. The other option would be to use the formula y equals a times 1 plus or minus r to the x. So again, we know that we're not going to leave it as plus or minus r. It's either going to be plus r if it's increasing or minus r if it's decreasing, and in this case we're decreasing. So we have y equals a times 1 minus r to the x. A is still our initial value, so this is our y-intercept. So in this case, it's 1,200 students. We initially had 1,200 students. 1 minus my rate. So my rate is 5%, which as a decimal is 0.05 to the x, and then simplify the parentheses. So that's 1,200, and then 1 minus 0.05 is 0.95 to the x. And so you can see that those equations are the same. One just got us there a little bit faster. This is how we're writing the equation for exponential functions.